This is lesson 8.5, which is again on constant rate of change and then direct variation. So, a couple problems for the warm-up. The first one says a ski lift goes from the base of a mountain to a point near the top of the mountain. After 3 minutes, the lift had traveled 200 feet. After 6 minutes, it's traveled 400 feet. Find the rate of change. So I'm just going to quickly make myself a little table where we have X as the minutes and Y as the feet. So we know that after 3 minutes, it's 200 feet. And after 6 minutes, it's 400 feet. So then to find the rate of change, I need to find the change in Y over the change in X. Again, I like to start with that bigger value first in my Y so that it stays positive. So I have 400 and 200. I'm finding the difference, so 400 minus 200. Those are my two Y values, and then my two X values. Since I started with 400, I have to start with 6. We have to stay consistent. 6 minus 3. So now I have 200 feet over 3 minutes. So after 3 minutes, it's traveled 200 feet. I need to make that a unit rate by dividing both by 3. So then I'm left with 1 minute. Remember, 2 labels. And 200 divided by 3 is 66.6 repeating, so we'll do 66.67 feet. So every minute, this ski lift is going up 66.67 feet. Number 2 says find the X and Y intercepts and then graph the equation. So we're given this equation 4x plus y equals 8. To find the X-intercept, we're going to plug a 0 in for y and solve for x. So I get 4x plus 0 equals 8. This really just narrows down to 4x equals 8. To get x by itself, I'm going to divide both sides by 4. And I'm left with x equals 2. We always write our intercepts as ordered pairs. So x is 2, and y we plugged in a 0, so y is 0. Then for our y-intercept, we're going to do the same thing, except this time we're going to plug a 0 in for x and solve for y. So we have 4 times 0 plus y equals 8. 4 times 0 is 0. So we just have 0 plus y, which is just y equals 8. We have to write that as an ordered pair. So when x is 0, y is 8. Now I have my two intercepts. I'm going to plot these. So my x-intercept is where my line is going to cross my x-axis, and that's going to be at 2, 0. So I'm going to plot that point. My y-intercept is where my line crosses the y-axis, and that's going to be at 0, 8. Now that I have my 2 points, I can connect my line. And there we have it. Okay, a couple vocab words. Linear relationship is a relationship that has a straight line graph. So the word line is right in that. Linear relationship is a line. Constant rate of change is when the rate of change between two data points in a linear relationship are the same or constant. So when there's a constant rate of change, we're given a straight line, or there is a straight line. When there's a curved line, it is not a constant rate of change. So number 1 says the graph shows the amount of money in yen savings account each week. Find the constant rate of change, then interpret its meaning. So we're trying to find the constant rate of change. To do that, we need to find the change in y over the change in x. We know it's a constant rate of change because we have a straight line. So I'm going to use these 2 points that are given to us on our line, and I'm going to start with my y values. So it looks like we have 80 and 20. So I'm going to take 80 minus 20. Then for my change in x values, I have 4 and 1. Since I started with 80, the 4 corresponds with 80, so I have to start with my 4. 4 minus 1. Now I'm going to simplify this. So 80 minus 20 is 60, and that's going to be dollars. Over 4 minus 1 is 3 weeks. So now we have $60 over 3 weeks. We have to make that a unit rate, so I'm going to divide both by 3. And I'm left with $20 over 1 week. So when it says interpret its meaning, all that means is what you're saying is that every week, yen is saving $20 more. Proportional relationships are when the ratio of each y value compared to the x value is the same. So given a table where we have time is x and distance is y, we're going to take y over x and find the ratio. So y over x, 4 over 1, which is 4. Then we're going to take 8 over 2, which is 4. And then we're going to take 12 over 3, which is 4. Since all of these ratios are equal, we know that it's proportional. So when you take y over x for each of the points and it's and they're all the same, then it is proportional. It's not proportional when you take y over x and they're different. So 4 over 1, we have 4. 6 over 2, we have 3. Well, 4 and 3 are not the same, so they're not proportional. They're not equal. Looking at the graphs, this is a graph of a non-proportional relationship. This is a graph of a proportional relationship. So if you're given a graph, super easy and quick, you can tell if it's proportional if it goes through the origin. So you should write that in your notes. It is proportional if it goes through the origin. So it has to go through that point 0, 0. That's the origin. If it doesn't go through the origin, not proportional. Right away we can tell that. So looking at this graph, it says the graph shows distances that a cyclist rides. Determine if there is a proportional linear relationship between the time and distance. Show your work. So just by looking at it right away, this line does not go through the origin. It does not go through 0, 0. Boom, it is not proportional. But to show our work, to just double check, all we have to do is take a couple y over x values for these points and see if they're the same. So for this first point, it looks like we have 15 and 6. So 6 is our y value, 15 is our x value. I'm going to simplify this, divide each by 3, and I'm left with 2/5. And then my next point, my y value is 9, and my x value is 30. Simplify this, and I'm left with 3/10. Well, 2/5 and 3/10 are not the same. The ratio is not consistent, so it is not proportional. So there's the two ways to tell. Look at the graph, check the ratios. If the ratios are all the same and the graph goes through the origin, it's proportional. If the ratios are different and the graph does not go through the origin, it's not proportional. As it is being dug, the depth of a hole for a backyard pond is recorded in a table. Find the constant rate of change and interpret its meaning. Then determine whether a proportional relationship exists between the two quantities. So there's a few things that we have to do here. The first is find the constant rate of change. So I'm going to label this to make it easier for myself. This is x and y. Find the rate of change. We're going to find the change in y over the change in x. I'm going to pick any 2 points here, so I'm just going to pick the first two. Change in y. I'm going to start with that bigger value, so I'm going to do 16 minus 8. So those are my two y values. And then since I started with 16, I'm going to start with 20. So 20 minus 10 for my x values. Then I'm going to simplify this. So I have 8 inches over 10 minutes. We need to get this to a unit rate, which means the bottom needs to be 1. So I'm going to divide both of these by 10. And I'm left with every minute we dig. So I'm going to take 8 divided by 10, and I get 0.8 inches. So every minute, another 0.8 inches is dug. Then it says, determine whether a proportional linear relationship exists. So all I'm going to do for that is to just check a couple of these values, y over x, and see if that ratio is the same. So I'll start with the first one, 8 over 10. I'm going to simplify that to divide both by 2, so I have 4/5. Then I am going to, let's just choose the last one. 32 is y, so I have 32 over 40. Doesn't matter which ones you pick. I'm going to divide both by 8. And I'm left with 4 over 5. Well, those ratios are the same, so yes, it is proportional. If we were to graph this out, that means that our